right, we're going to be working in Volume 2 book. We're on our first lesson of Chapter 5 and our first page that we can work on in our Volume 2 book. We will be working on page 153. Rename each fraction as a whole number or mixed number. So we're going to go ahead, and I like to use graph paper. And if I look back at my notes, I'll recall that I'm going to divide to do this. So go ahead, take 8, my denominator, and divide by my numerator, or divide into my numerator. 8 can't go in a 2. 8 goes into 24 3 times. Well, that's nice and even. So that is a whole number. So 24 eighths is the same as 3, or equivalent to 3. 18 fifths, I'm going to take my numerator, make that my dividend, my denominator, my divisor. 5 goes into 18 3 times. 5 times 3 is 15. Subtract. All my remainders need to be reported as a fraction. So this would be reported as 3 fifths. 3 and 3 fifths. All right, 21 sixths. It's like saying if I have 6 whole pizzas, I have 21 pieces. How many do I actually have? How many whole pizzas do I actually have? Or sorry, if I have 6 pieces complete my pizza or make up my pizza, and I have 21 pieces, how many whole pizzas do I have? 6 goes into 21 3 times. 6 times 3 is 18. 11 minus 8 is 3. My remainder becomes my numerator, and my denominator stays the same. All right, now I have 15 fourths. 4 goes into 15. I got to think about how many times using multiplication. 3 times. So 3 is my whole number, and 3 is my remainder, which is my numerator, and my denominator stays the same. So 15 fourths is equivalent to 3 and 3 fourths. Now my final fraction to convert here is 11 thirds. That means 11 pieces make a whole. And I'm sorry, 3 pieces make a whole, and I have 11 pieces. 3 goes in 11 3 times. My remainder becomes my numerator, and my denominator stays the same, and it's the divisor, 3 and 2/3. So if I have, let's see, 3. If I cut my pie into 3 pieces and I have 11 pieces of pie, how many pies did I start with? I started with 3 and 2/3 of a pie. Those would be some pretty big pieces of pie, or maybe it's just a small pie. Write the following decimals using numerals. 3 and, well, that tells me that everything is in front of the decimal there. 6 hundredths. So I got to really think about this. 6 hundredths would be, here's the tenths place and here's the hundredths place. There's nothing in the tenths place because we just have 6 hundredths, because that 6 needed to go in the hundredths place. 12 and 9 thousandths. Wow. So I'm going to go with 12 and thousandths. So here's my tenths, my hundredths, and my thousandths, and I'm going to put that here to kind of help me out, and I want to start at the end, and I have the number 12, so I'm going to put a 0 here, and that's what 12, oops, sorry, not 9, it should be 9. I'm going to start at the end again, and that 9 is in the thousandths place, and 0 in the hundredths and the tenths place. 70 and 1/10, so 70 decimal, a 1 in the tenths place. There are 107 girls at a hockey camp. The coach is reserving rinks for games. There can only be 12 girls on each rink. How many rinks should the girls reserve? So this is a division problem. I have 107 to start with and 12 left over. That's going to tell me R for rink. What is my solution? I can turn my page just like this to help me set up here. It's kind of tight though. So I think I'm going to use my graph paper instead. So I have 12 girls per rink and 107 girls. 12 goes in a 1, 0 times. 12 goes in a 10, 0 times. Now if I'm stuck here, I could use my multiplication chart. Because 12 is a math fact. And go to my 12 row. How many 12s go in 107 without going over? Well, 9 would be 108, so it has to be 8. So 8 times 12 is 96. I need to make sure that I do my regrouping when I subtract. So 11 girls can't skate. Well, that wouldn't be very fair. So what we're going to do is we have to think about, well, what should we do for those 11 girls? Well, 11 represents leftover girls. What should we do for those girls? I think we're going to go with 9 ice rinks instead of 8. So these 11 girls have a place to skate. So we need 11 rinks. Sorry, not 11 rinks, 9 rinks. Oh my goodness, I am really jumbling my words lately. Carlos rode for 2 hours while training for a bicycle race. In the first hour, he rode 15 7/10 of a mile. In the second hour, he rode 14 5/10 of a mile. Which number model would you use to find the total miles he rode in 2 hours? So total. So we're going to do some addition here. We're going to start with 15 7/10, and we're going to add 14 5/10. And this plus 2 is here to trick you. We're not really adding the 2 because in the first hour he rides 15 7/10. In the second hour he rides 14 6/10. So nothing with that 2. Same here. We're not multiplying it. All we would do is add straight across. All right, number 5, and it's not a written problem like it normally is. Write the ordered pair for each coordinate grid. Now remember, ordered pair goes X, then Y. X comes first in the alphabet. Here's my X axis, although that X I just wrote looks like a Y. And here's my Y axis, and this is the origin. Okay. So A comes down to 6 on the A and 6 on the Y. B, so see how it's right on this line? For X, that's a 0. And then if we go up to Y, that's a 3. Now C is on the line, but it's on the X. Sorry, it's on the Y, because here's my 0. Even though it looks like it's on the X, it's really the 9th X, but it does not go up, so it's 0Y. Now D is 3 on the X and 7 on the Y, and E is 7 on the X, 3 on the Y. Those ones are flopped there, just so we can see that order does matter, because this is what 3/7 looks like for D, and this is what 7/3 looks like. So very different. So it's important we make sure we put these in the correct order.